Hi there. Thanks for joining us for today's webinar. This is Eva, the editor of Industrial Automation Asia, the frontrunner publication in industrial automation for professionals and executives living in Asia. The webinar is brought to you by Scheffler, a leading global supplier to the automotive and industrial sectors. Today, we're going to look at a comprehensive and automated condition monitoring that uses a highly scalable wireless Internet of Things solution that integrates easily to hundreds of assets in a single day. The speakers are also going to share how this easy-to-use, low-cost solution that is designed specifically for the comprehensive condition monitoring of all indirectly processed critical assets across entire machine and equipment parks. Let's introduce these speakers. Our first speaker is Shu Jun. She is the head of Industry 4.0 for Schaeffler Southeast Asia. Shujin leads a regional team to help Southeast Asia customers on their digital transformation journey. Her work includes educating customers on the importance of early identification of bearing faults and leverages on Scheffler's smart solutions to enhance the lifespan of their rotary machines. The second speaker we have is Putawong from the Industrial Technical Office, Scheffler, Thailand. Putawong is the head of Industrial Technical Office in Scheffler, Thailand, and plays an important role as a technical principal supporting Southeast Asia. He leads a team of technical and service experts in Thailand and is responsible for developing condition-based monitoring service solutions for regional customers. Before we begin, let's go through the webinar rundown. The webinar will begin with our first speaker, Shujin, followed by the second speaker, Putawong. There will be a question and answer session after the presentation. If you have any questions, please type it in the panel. We will select a few questions from the panel for the speakers during this session. Questions that are not answered during this session will be answered in text, and we will distribute all the Q&As to all the participants today after the webinar. All right, without further ado, I'll pass the stage to our first speaker, Shujin.
Thank you, Iva. I'm Shujin, the head of Industry 4.0 Southeast Asia, currently based in Singapore. And together with me, I have Kun Putawong, the head of Technical Office Southeast Asia, based in Thailand, Bangkok. So thank you again for the opportunity to work with IAA and allow us, the next 40 minutes or so to share and introduce a new era of condition monitoring with you. Now, the agenda for today will include 4 main topics. First, I'm going to share very briefly about Scheffler. And then secondly, how condition-based monitoring could help to improve your reliability metrics and as well as your company profitability. Third, we'll take a look at Uptime, our award-winning condition monitoring solution. And last but not least, Kun Putawong will share 3 very interesting case studies that he has worked on to resolve customer pain using Scheffler condition monitoring solution. Now, a quick glance of Scheffler. We're actually a global supplier in the industry and automotive sector. And, we have manufacturing plants as well as sales offices located in more than 50 countries around the world. Well, we started off as a bearing company, and we have more than 138 years of proven expertise with a strong presence in Asia. Some of the brands that you will be familiar with will include the FFG as well as the INA bearings. Okay, now we come to the more interesting part where we'll discuss about how condition-based monitoring could help to improve your reliability metrics and profitability. Well, Scheffler has worked with various customers as well as various industry. And after talking to them, we realized that the cost of production downtime or unplanned shutdown could actually be very expensive, and it could hurt your bottom line, your company's bottom line significantly. So we do understand the pain that you are having right now to minimize this unplanned downtime for you. So in the market, there are several handful of maintenance strategies that could be deployed, namely from the reactive, preventive, predictive to proactiveness. And there is generally a relationship to relate this maintenance strategy to OEE, or what we call the overall equipment effectiveness, that a simple formula calculates the availability, productivity, as well as quality. So the gist of it is we try to maximize OEE to improve efficiency of your plant. And if you look at the particular slide, most of our customers will want to work towards the target zone where your machines are predictive, and then you can also deploy a proactive strategy moving forward. And the rationale for us linking your maintenance strategy to the OEE in a sense is that in some business, a 1% improvement in your OEE could result in more than $1 million savings. So ultimately, your company bottom line and P&L will be improved along the way too. So this is a typical PF curve that most of you will be familiar with. On the y-axis, you do have the machine condition, and on the x-axis, the unit will be time. So we do know that all machines, be it a new or reserviced, reconditioned machine, will degrade or deteriorate over time. There is nothing we can do about it, due to wear and tear. But what we can do to help you is that we'll help you to intervene at the right time to minimize serious business consequences. So take, for example, in the area of P and F, this is where your optimized area where you could step in with your optimized business investment so that you do not spend too much or too late to repair your machine at this time. So how can Scheffler help you? So what Scheffler can do to help you is we could step in at a particular point, that is the P, where we could have an early detection of your bearing and gear mesh damages, where we could listen and understand what sort of vibration damages that you are having, together with our 3 condition monitoring solution that you are seeing online right now. So what does this imply for you and your business is we allow you to have a significant lead time for you to plan and schedule for your shutdown, to buy in the spare parts, as well as to plan for your inventory management. So Scheffler has 3 condition monitoring solutions for you, namely the Uptime, the Smart Check, and ProLink condition monitoring solution. So depending on your needs and application, the operating conditions, we would like to discuss holistically with you on the type of solution to be employed at your site. Say, for example, you have a fixed machine that you will want to look at, so probably Uptime could be a good solution for you. Versus, you are operating a compressor that has varying load throughout the day based on the load interprocessors, and that it has to be monitored continuously. And perhaps a ProLink with a 16-channel will be the right solution for you as well. So after talking to numerous customers, we do realize that a lot of customers, having say many assets that they have, most of them only have about 6% of them would be critical asset, which they are continuously monitoring right now. So they have the budget to spend on this 24/7 monitoring. Take, for example, like a compressor, unplanned shutdown could cause millions of dollars of production loss, and they're willing to spend for it. But how about your secondary equipment where you have totally no visibility at all? So most of the customers we speak to tend to have 2 approaches. One is every month they have a portable offline system when they get their technician or engineer to go around the site using a handheld devices to gather the vibration data. This is actually a very labor and time consuming activity. And we do have a solution to say that, perhaps your resources and your budget could be put to better use so that, when there's a more urgent task on hand, you do have the available resources to work on it. Well, the other approach that, like that customer or a feedback that we do receive most of the time is, I have a plant that is already running for 20 years, and the investment cost to put in extra cabling or trunking, to get my contractor in is significant, and they're not willing to invest in that. So this is why most of them might not have a full visibility of your asset at the plant right now. And this is something that we think there's a gap that we could help you with our Uptime solution for your remaining 94% of what we call a balance of plant. So the Uptime is something that is really easy, cost-effective, and highly scalable that we could help you to tackle your unplanned downtime holistically. So for example, if you're looking at your critical asset, we do highly recommend, a smart check or ProLink solution where we can continuously online monitor it for you 24/7. But for the remaining balance of plant where it's not so critical, perhaps Uptime would be a good solution for you because it's totally, wireless. And the beauty of Uptime is once this data is gathered, it will be transmitted into our gateway, when this information will be transmitted into a Scheffler cloud. Please be assured that your data is totally secured with a Scheffler cloud technology. With our bearing knowledge as well as our condition monitoring expertise, we will do all the data crunching for you. We do all the analysis for you in the cloud, and conveniently you get to access this data via your dashboard and your smartphone anytime, anywhere, as and when you like it. This is especially critical in times of COVID, where like workers are not allowed to go to site and you are not able to go to your control room at all. So having access to this data anywhere will be a critical moving forward. And of course, some customers also feedback, I do not like to have two separate systems between your Uptime and your Smart Check and ProLink. So please be assured that we have also engineered this into our solution, is that you can also access the data captured from Smart Check and ProLink either locally to your PLC, or we can also link them up to a Scheffler secured cloud where you can also access this data anytime that you like. So what is Uptime? So you can see that Uptime, we do have two different models, namely the AW3 as well as the AW5. So how it works is depending on the RPM, rotating speed of your machine, it can range from 100 to 5,000 RPM. So this system can be easily expandable, and definitely you can see from the slide, it is wireless and power battery vibration sensor. Then the gateway will transmit the information to our cloud, and of course we have an app that you can download in your smartphone, be it an Apple or Android phone, conveniently for your usage. And how Uptime works is really very simple. We have gone through many rounds, of design, and the concept that we come up with is Uptime will be plug, play, and predict. Plug because it's really simple to install. Take for example, once you have a list of machines, 94% of them, and installing them going to take lots of time. So what can be done is, you install it, just take 2 minutes of your time. 2 times 94, of course, with the distance in between, is really going to be easy to implement along the way. And what does it mean by extendable or scalable? Well, for a start, some customer will say, oh, I have this particular heating area. Perhaps I would like to try with only one gateway and 20 sensors for a start. After 3 months, you do realize the true benefits of Uptime, and you're interested to purchase more sensor, say additional 30. And in this aspect is within the same area, as long as it is a 100-meter line of sight, you can be assured that your data will be transmitted to the gateway without any significant increase in your investment cost. That is to say, the more you buy, your return on investment as you scale up will be better returns moving forward. So this is plug, play, and predict for you for Uptime. So Uptime consists of 3 solutions: the sensor, the gateway, and of course the digital service. It is actually really a subscription-based system designed for fixed speed machine and your balance of plant, and is engineered for large deployment via our mesh network backbone, which I will talk more in the following slide. It's definitely very cost effective, easy to deploy, less than 2 minutes to install, and easy to use, and it's a completely wireless solution. So for your existing plant that is currently running and you do not want to have extra costs for cabling, trunking, this will be the ideal solution for you to have a full visibility of your plant right now. So of course, what is the mesh network? Well, it's simply put, it's a self-healing technology where you can see on the screen, the green triangles represent each sensor. Each sensor is a receiver as well as a transmitter. So what it does is for every 4 hours, it will gather the information and then it will transmit to the next sensor and move on and find its way ultimately to the gateway to be transmitted to our Scheffler cloud. In the event if one of the sensor is failed or overloaded, like shown in red, do not worry, there's no configuration, no intervention needed by your end because the sensor is smart enough that it will self-heal itself. It will find the next sensor and find its way ultimately to the gateway. So it's really a very easy, once you install it, install and forget. That is the whole motto of Uptime. So of course, what can you get out from the dashboard and app? Just a quick, simple illustration. Once you log in, you get a clear overview of your assets health. Take, for instance, the alarms and alert. You can see for a glance whether it's in red, orange, or green. So pointing particularly specific machines that you do need to take note of for the day. So you can arrange, for your resources accordingly to take a look at the machine to go down to site as well. And of course, we have 6 months of data trending available that you have a historical records of the past records as well. So in short, the Uptime is really a very efficient and simple solution that you could install it immediately. So if you are interested to learn more about it, do talk to your local sales Scheffler officers, or you can approach me and Kun Puchong at the end of the webinar. I'll be more than happy to connect with you to discuss more moving forward. So moving on to the next part, where I'm really excited that Kun Puchong will be here to share, a technical discussion on the case study that he has helped our customer in Southeast Asia to, resolve their pain. So without wasting too much of time, I'll pass the time over to Kun Puchong. Kun Puchong, over to you.
Thank you, Shu Jun. Hello, my name is Puchong Putuong from Scheffler, Thailand. I'm the service manager, and it's my pleasure to provide a case study to you. Come to the first case study. This is automotive part manufacturer. This project started 2 years ago. In order to get reliability of the plant with the suitable maintenance management, Scheffler provide a holistic solution. We implementing ProLink, Smart Check, and Uptime. For the ProLink, we install 5 sensors to very critical machine like compressor. And the Smart Check, we install 60 sensors for the second level of criticality of the machine. And the third one is the Uptime. We install 164 sensors for the balance of the plant. For the Uptime, we install to the equipment which is have constant speed and constant load. This is very good information from the system that we present the status of the machine on the dashboard. From the dashboard, it can deliver the status from the sensor. For example, the battery of the Uptime, we can see how many sensor is low battery. We can see how many sensor is out of the connection. For example, from the data you will see is 24 of the sensor is disconnect. It might be because of the electrical shutdown. And also the dashboard is provide you the information for the new sensor that we just installed. When we install the new sensor, the sensor will have learning mode. The learning mode is mean we take the sampling of the data. It's about 1,000 sampling and calculate the suitable alarm for each level of the vibration sensor. Because of every position, every measurement, the vibration level might be different. From the status, you can see the condition of the machine in green, yellow, and red. And all these things you can click to see the notification in each machine. From this dashboard, we can go more to analyze the trend of the data. This is very important data that screen the status of the machine. This is in the smiling face on my presentation because of from the main KPI. The KPI that we are very emphasize when we make analysis. One is ISO, is mean the vibration in velocity. The second very important KPI is called demod or demodulation. The demodulation is the vibration in acceleration. The vibration in demodulation is tell you very precise the condition of the bearing and lubrication, and if the gear teeth, it can also tell the condition of the gear teeth. The demodulation is very important to analyze high frequency vibration. And the last KPI for the smart check and uptime sensor is also can provide the temperature of the surface of the machine. So from these three KPIs, you can see the trend. Up to 6 months, you can select the view from 1 month, 3 months, and 6 months. Even you can select the specific view from date to date, something like that. From this one, you can see when the machine start and stop, but overall, you can see the trend of the vibration is quite stable and the condition is good condition. Go to the next slide. It's also the model. That is the data that we would like to get from our machine because we want to see our machine is in good condition. Again, this is a KPI from the model that you can see the trend is very smooth and easy to make judgment. This is very good for you, for maintenance team to realize this is a good machine. And also this data from uptime sensor, not only the trend, when something happens, you would like to make analysis more. The data can be provided spectrum analysis and also the waveform. You can compare the spectrum from day to day. We have the record to analyze. From the uptime, we have the reference spectrum in daily data. For the smart check and polling, you can select the time interval to correct the data, spectrum, and waveform. Okay. Now I will come a little bit more in technical to make analyze and understand the characteristic from what we study from the trend of the machine. You will see this, there is notification on the motor that there is a LED alarm in the motor. When you look up to the data, you will see the LED alarm. What is the KPI to alarm this? You can see the alarm is come from the temperature. From time to time, the temperature is reached in very high temperature compared to the average temperature. Now, when we look to the trend of 3 KPI, we will know the characteristic of this machine. The temperature will reach when the machine is stopped. When you see the arrow that I point out from the trend, when machine stop, the temperature increase. After we investigate on this, and we know that when machine stop, this machine is accumulate the temperature around that area is quite confined space, something like that. That's why the temperature is reached until it's alarmed. So this case is mean that the machine is not really have the problem. It's just like a characteristic that when the ventilation at the end of the motor is not work and in the confined space, the temperature is will reach from time to time. So on this one, the maintenance team just recognize the notification and said that, hey, I understand this problem is not a big deal. So I close the case. This is normal. Overall, from the trend, you can still see the trend on average, both KPI in ISO velocity, acceleration, demodulation, and temperature is on average is quite smooth. So on this case, we understand the point and we recognize this is not a big problem. This is actually it's not problem at all. We recognize it's normal case. We understand the characteristic of this. This is one of the example that when we see very good trend, very good status of the machine, and we know how to make analysis and notification on this. Okay. The key to take away from this case is harmonized view on the health of your asset is very important, and it helps you to make the right judgment. And from the data, Scheffler dashboard that we design is can up to 6 months to virtual KPI training. This one is normally based on the uptime, but for the other data, we can see more if we have the server to see the history of the data of the trend more than 6 months if we download the data from Smart Check and polling to the server. And we can access this data anytime, anywhere via mobile application and dashboard. Our application is free from iOS and Android, so it's very easy to use. Now we come to the second case. This is the different customer. The customer is chemical process manufacturing. We have more background on this project. Okay. The background is Scheffler. We provide a monthly load-based service with the portable device for the total more than 100 machine. And this is we service every month. It's monthly load-based service. We serve this customer for several years, and the list of the machine consists of motor, pump, decanter, and agitator. Okay. Based on the history, we have issue emergency case with the agitator from because of the vibration just increase up, and the customer is worried when the trend is going quite high level from the average level. So many times, not few times, the customer call us, and after that, when we just retake the measurement, the data it just come down to the normal level. This is I want to show you the trend data on the top that we provide the monthly load-based service. The data is quite up and down, is swing, is fluctuate. Why is fluctuate? After we study more, we know that the data is quite depend on the load of the agitated tank under the machine. When the load is like 90%, 100%, is mean fully tank. The tank is more rigid, so the vibration in velocity level is quite low. But when the load level of the liquid in the tank is in low level, maybe 10%, 20%, the tank is not rigid. The vibration is more, the tank is more shaking, so the velocity vibration is increased, something like that. So you will see on the top, the trending from the load-based data is swing all the time. When we analyze the frequency of the failure, we see nothing, only the main process frequency, something like that. And also, if you know that when the machine is quite shaking, something like that, always sometimes it's excited to the resonant frequency of the tank. That's why the data is always up and down. When you see the data up and down swinging like this, I can say that when you make the analysis, the first data that you will view the data is not the spectrum. You view the trending of the data first. When you see the trend like this, you will realize that, hey, I have to make analysis more, and you have to take time to make analyze on this. So it's take more time for analyze, and after you analyze, it's nothing there. It's take more for the time. So when you change the trending from monthly base by we are providing the smart check. The smart check can be customized the time interval for the data to see the trend. So we can find the good resolution of the trend from the data below. On the left, you can see the trend is very fine. Even that is the fluctuate the data. When on the top you will see the very tight data, something like that. It means the data is fluctuate from the low. When the machine stop, it just go to the zero vibration, something like that. By the way, you can see very clear average data. This is the data is 1 year period of this trend. The trend increase slowly, something like that. You can see this is the develop of the vibration trend is slowly increase a little bit. On the right hand side right now, when the trend is drastic, increase, you will see this is really abnormal case for the machine. We can recognize after that we make the vibration spectrum analysis. From this increase of the trend from the smart check, after we look to the demodulation data, you can see this is the analysis of the frequency. You see one time with many harmonics from the gear. This is data spectrum of the gear. Not only the one time with many harmonics, you can see clearly the GMF and the harmonic of the GMF more than 3 harmonics, something like that. And also you can see the sideband of the gear made frequency. The sideband level compared to the GMF level is comparative, is high. You can see the portion of the sideband level is quite high compared to the GMF. So on this part, spectrum analysis tell us there is like worn out or looseness of the gear. After we take the gear out from maintenance plan, we swap the new gear. We replace the new gear instead of this gear. We investigate the damage of the gear. We found that the gear teeth on the left-hand side is really worn out. This one, we clearly that our trending and our spectrum deliver the accurate data that tell you the condition of the gear. So from this case, we can save 5 days of the maintenance because of if you have unplanned shutdown, the customer not prepare for the maintenance. They not prepare for the crane because of this gear, even it's not really big gear, something like that, but it's on the 3rd floor. When you would like to replace this gear, you have to prepare the crane, you have to prepare the manpower, you have to prepare the right to take out and replace gear from the 3rd floor to the ground. We save 5 days. And also if you calculate the cost of saving is about 25,000 saved because the unplanned. If you have unplanned, the other part of the gear might be damaged. This is very good case study, and the result from we improve of the resolution of the trending of the data. The key to take away on this is continuous online monitoring critical assets are essential. The second key takeaway is to apply right condition monitoring to enhance predictive maintenance strategy will help the total cost of ownership. Now we come to the case number 3. Actually, I said that this case is continue from the second case. We still in the same chemical process manufacturing. After we know that the continuous trend of the vibration data improve the analysis and deliver more precise of the accurate condition of the equipment. And beside better trend, we also recognize that we can reduce the manpower in data collecting and also the manpower from analysis that I tell you that the training is help you to screen the data for the analysis. Compared to the monthly loose-based service, this will save time and money. So then we discuss with the customer and we find a way to improve the system by try to convert the offline measurement by uptime. Because of uptime is very economic of scale to invest and very compared to the offline service. As Shu Jun say, it's very easy to install, take very short time to in the initial phase to make the configuration of the uptime. So we make decision to install uptime as many to the basic machine like constant speed of the motor, pump, and fan. And we get the data again from the dashboard. This is, I emphasize again, uptime is just plug, play, and predict with very short time. Okay, so This case is just how to manage the data and improve the maintenance management system by try to figure out of the comprehensive solution for the customer. So the key to take away on this is to increase visibility of the auxiliary machine help with the online uptime solution. It will help you. System can be scaled up anytime very easily. This is all of my 3 cases for you, and I hope that is interesting for you. So maybe Shu Jun, maybe you can make the summarize from the overall picture again, please.
Sure, thank you, Kun Puchong. So, so just to wrap up this webinar, so on this slide, we do have 4 particular key takeaways that we have to summarize as we introduce a new era of condition monitoring for you. So be it your critical asset or your balance of plant, Scheffler has a very comprehensive solution, of ProLink, SmartCheck, and Uptime to cover most application, or if not all application, based on whatever you need and the operating condition as well. Scheffler also has the right domain technical know-how because we have the bearings expertise as well as our condition monitoring knowledge to help you implement the right predictive maintenance for your rotary asset. We also have proven SmartCheck and ProLink solutions with very strong local support that you can be assured that you will get the most out of your assets as well as the highest return of investment. And last but not least, do engage Scheffler to understand more on how we could help you reduce your total cost of ownership with a very scalable and cost-effective uptime solution. So with this, I'd like to thank you for your time for the past 40 minutes. And if you have any questions, please feel free to drop me or Kun Puchong an email. I will be glad to follow up with you to discuss more as well.
Thank you.
Okay, thanks everyone. Okay, now I'm seeing there's just a few questions already. So now let's bring back the speakers for the Q&A session. Okay, let's go to the first question. This question, what are the different types of condition monitoring that the product offers? Speakers, can you hear my question?
Yep.
Okay. Kun Puchong, please go ahead.
Yep. Scheffler, we have 3 products for condition monitoring. We have ProLink for very critical machine. It can be set up and configure and connect to the standard vibration sensor to install any condition of the machine. The second is SmartCheck. It's the smart sensor. Is a little bit have to be wide system into the router and into the system. And the last one is the Uptime. Uptime is very smart sensor. It's totally wireless sensor based on battery. Is provide 1 axis and 3 axis type of the Uptime. All these 3 system we connect to the Scheffler dashboard to see the same interface of the software. And we also have like a portable detector 3 device in order to correct the load-based vibration. This is our product range from the Scheffler to provide a solution.
Thank you. Okay, we move on to the next question. What are the typical cost savings customers can achieve when they use the condition monitoring solution? speakers? Shujin?
Hi, yes, Ifa, thank you. Well, this is actually a very good question. So I would say it actually depends on customer per customer basis because of the different products that they are actually producing or manufacturing. But as a general overview, I would say that, you know, we have done some research along the way and of course talked to our customer, and we found that most companies actually have experienced unplanned downtime, like 82% most of the time. And some of the average, you know, costs that could be lost includes, you know, the loss of production revenue, that's one. And of course, in some cases, you know, the financial penalties that come along with it. When your staff, you know, when maybe you have catered for them to run the full production, but unexpectedly it came down. So your loss of staff time as well as to restart the line. These are all very costly, and a rough estimate in a way that based on this factor, it could cost maybe like 150, maybe about 500,000 per hour with all the, you know, not just one application, because if your upstream is affected, all your downstreams, everything could be affected as well. So as a conservative number, it could, you know, range anywhere from €500,000 up to $1 million production per hour. So yeah, these are very costly, unplanned downtime that we do see our customer experiencing. Back to you, Aifa.
Okay, we have a next question. Okay, this is from the chat. The uptime sensor is a 3-axis or single axis. This is the first question. And the second question is, what is the parameters of the vibration, frequency and velocity? What about FFT?
I take care of this question. It's quite technical. Uptime, we have two types of the sensor. We have uptime AW3, is mean this is single axis. And we have uptime AW5. This type is 3 axis for vibration. Uptime and smart check, even the blowing, the vibration parameter is mean we can select the parameter velocity, acceleration, and also we can collect the spectrum, waveform, and overall data. We can set the configuration to get the right information for the customer. We can do the all data or parameter of the vibration data and to show on the dashboard. This is my answer.
Okay, thank you. And we have another question.
How does the Scheffler dashboard?
How are the sensors physically mounted onto the machines?
Again, this is quite technical. Actually, the position that the sensor will mount on the machine, we would like to install the sensor to the closest position to the bearings, because the bearing is gather all the force from the shaft from the load of the machine. So theory, we try to mount the sensor closest to the position of the bearings. This is the first idea.
Okay, another question. Are those battery replaceable for the sensors, I think?
I can take this question, I
Okay.
thought. Yeah. So again, I think this is a good question. So are those battery in the Uptime sensor replaceable? Well, maybe for a start, I'd like to maybe give more specification of the sensor, that it is actually an IP69K rated product. So what this means is, you know, it's actually the highest IP rating available and is able to withstand very intensive cleaning with high pressure and high temperature jet. Example, in an F&B, where we can actually experience a wash down for sanitation requirements. So what this means is, you know, as is IP69 rated, the battery would then be non-replaceable because we cannot open it and unscrew it. If not, the IP69K will be void. So what this means is once the battery has run out or is low, you can simply replace the sensor, the Uptime sensor, with another one. And in the app on your smartphone, you can just press a button that has a replace sensor. So you can just take the old one out and then you just screw it with the new one, and it can just automatically seamlessly connect to the gateway, and you can just continue your condition monitoring thereafter. Yeah, that's all from me.
Thank you, Shujin. Okay, another question. How does the Scheffler dashboard compare with the trade line software available for Detector 3?
Is totally different between the Scheffler dashboard and trade line. First, Scheffler dashboard can be run on the cloud and also from the smart web, something like that. So is can access through the application. Totally different of the design, and for the online, we would recommend the Scheffler dashboard and smart web, something like this.
Okay, there's another question on battery. What is the expected life of battery in sensor?
Okay, I'll take that question with regards to battery. So the uptime by default is set to a 4-hour timeline, where every 4 hours it will start pulling in data gathered from your machines. So of course, this 4 hour can be configured differently. So based on our 4-hour default setting, it can last between 3 to 5 years. These are the tested conditions. So of course, if you like to have more data, like instead of 4 hours, you want it every 1 hour. So obviously the lifespan of the data will be shortened significantly as well. So I would say probably a good 3 to 5 years. That will be a general expectation. And it's probably also similar to a lot of the lithium batteries available in the industry at the moment. That's all from me.
Okay, thank you. The next question. How many sensors are there per gateway?
Shu Jun, I can say 50 to 70 sensor can be connected to the gateway. One gateway, we can install more gateway to complete. It's very depend on the site situation. What is the position we mount the gateway, and what is the position of the sensor? But on technically is 50 sensor is convenient for one gateway.
Okay, the next question. Are there any calibrations required during the sensor lifetime?
Actually, I say that uptime we no need to calibrate the sensor. Yep. Even smart check actually is very stable for the vibration data. Is not the static data. Actually, the vibration is dynamic data. We just keep monitor and check the sensor. If its setup is okay, no need to calibrate. Hello.
Okay, we have come to the end of the webinar. We are actually having for any added questions. Later on, we will reply to you via email. Okay, and we have one more question before we end the webinar. How does the mesh recognize when a particular uptime has run out of battery, since it no longer has the capability to communicate?
Okay, I'll take this last question before the webinar ends. So I think in the earlier session, Kun Puchon did explain that in the dashboard, in the Uptime dashboard, we do have a icon that shows you is low battery, but it doesn't mean that the battery will deplete immediately. It gives you significant time so that you know that this battery is running low, so that you could have time, to go and replace it. So strategy deployment could be you have some spares on hand as inventory, so that when it runs out, you do have the uptime on hand to change up to do the necessary replacement at once. It's just like your handphone, it doesn't die immediately, but for uptime, it's reflected in the dashboard, so you can be assured that you can see, you can go in and click which are the sensors that have the low battery on which asset.
Correct, Shu Jun. And I will add more. When you replace the new uptime to replace the existing one, you just clone we have the function to clone the existing one. So very easy data transfer.
Okay, thanks Kun Puchong and Shujin. Thanks to all the speakers and thanks to all the attendees. We have, it's already 3 p.m. We have reached the end of the webinar. If you have any additional questions, please, you can email directly to the speakers. Their email addresses are displayed on the screen right now. We will also reply to all the additional questions that we didn't cover during this live webinar. We will email to all the participants after this webinar. All right, thank you everyone, and thanks for your time for joining us. And that's all for now.
Thank you. ขอบคุณครับ